Now we're going to study how to find an exponential function according to certain conditions. So in this case we have a exponential function that follows the form n equals n sub naught e to the kt. We have condition 1 that n evaluated at 0 equals 10. What does it mean that n is evaluated at 0? Remember, n is a function of t. That means that whatever t is, we're going to replace 0, and whatever n is, we're going to put 10. So replacing, we obtain 10 equals n sub naught e to the k times 0. So this entire part goes to 1. Therefore, we have that n naught equals 10. Okay, this is part of the answer. We're not there yet. Now we have to use the condition condition 2. And what is the condition 2? Condition 2 tells us that n evaluated at 5 equals 15. So we have to replace these values again, and we obtain 15 equals 10 e to the 5k. Now observe something. Where is this 15 coming from? This 15 is from here. Where is this 10 coming from? This 10 comes from here. This is the n naught. What is 5? 5 comes from the fact that the time was given as 5, and remember that this is e to the kt. So we have to solve for k. And how do we do that? Well, at this point you should know that we are going to divide both sides by 10, so we leave the exponential function alone. So we have that 15 over 10 equals e to the 5k. We're going to take logarithm, and then we have logarithm of, I'm going to do all the operations here. 15 divided 10 is going to be 3/2 equals 5k, from where k is simply 1/5 natural log of 3/2. Okay, so we found another little piece of the puzzle, but that is not all. We still have to do one more thing, and the additional thing that we have to do is to use this piece of information and this piece of information to find the final answer. What is the final answer? That is the expression. What is the equation? It's going to be n as a function of t equals 10 e 2 of 3/2 divided by 5. So we just take this k and it should be put here, and then we have it right here, and that is the correct answer.